the thumbs up or
That
a
was,
different thumbs up?
that
Okay.
was, hold on, the
It's
thumbs
the
up.
thumbs up. I'm ready to go. The producer has said I'm good to go here. So, hi, I'm TK Kugler. I'm the co-founder of Wasabi Ventures. Thanks for coming out today. It was great to see lots of new faces and people I don't know, so it's always wonderful. I'm going to be brief, which if you know me is really hard, but I'm going to really try to do it. So, what you're going to see today is really a culmination of programs that we've been running around the country for years. And we were really happy and really excited that we were able to do this program here in New Hampshire this year. And it's real, true STEM education. I'm a firm believer, and if you follow me on anything I write about, I talk about experiential learning as the only type of learning that really matters. And so what you're going to see today is real things being done by real students. And it's not made up projects, it's a real thing that solves a real business problem in the world. And we couldn't be more tickled and happy to have you here and have the students tell what they've learned. So with all that, I'll hand it over to whoever's next. Absolutely.
And I'm the Dean of Content and Instruction at Wasabi Ventures Academy. And so I ran the ed piece of this program, teaching them about the life of an entrepreneur. And so over the last 6 weeks, we've covered things like, simple things like what's a startup, what is a founder, and really helped define some of these things for these 4 guys. And so my piece was a little bit smaller in it. Their focus really was in the tech side, but it was good to round out their education so that not only were they improving their coding skills, but learning about what they could possibly do in the future in the entrepreneurial world. And so to keep this brief, if you want to learn more about us, you can go to academy.wasabiventures.com. We have online programming in case maybe some of you want to learn a little bit more about the entrepreneurial world as well. So thanks for coming today.
Thanks, Michelle.
David? No. We're on the side here. Doubling as cameraman.
Make sure you're in the picture.
I have to stand right here. I'm David Reese. I'm product manager at Treasure IP and associate at Wasabi Ventures. Like every good startup, Treasure IP started with a problem. In this case, a patent licensing problem. Over the last couple of years, Wasabi Ventures has been working with some military laboratories, research laboratories around the country, to help them commercialize their IP, their intellectual property. And we realized that although they actually have a directive to commercialize as part of their job, they have great difficulty doing so. To commercialize your patents, you actually need entrepreneurs to come in and license those patents, pay money for them, and to build products and companies around them. And labs just don't have the tools or the resources, or in some cases, the desire to fool with it. They have great difficulties getting it done. On the other hand, if you're an entrepreneur, how do you find the right patent to commercialize among the 300,000 patents granted every year in the United States and almost 100 million patents on the books worldwide? So both the labs and the entrepreneurs have a bit of a needle in a haystack problem here. Treasure IP is our solution to this problem. We offer a patent search engine and platform that helps labs put their best patents in front of the best entrepreneurs. We let the entrepreneurs search the complete United States Patent Office database. We suggest patents they may not have thought of based on their interests. We let them pull up additional data about the patents they're looking at. We let them save the patents they're interested in to a wish list, and we help get them licensing information from the laboratories. So basically, think Google search plus Amazon Marketplace for patents. I'm almost finished. As product manager of Treasure IP, I just want to take the opportunity to say that it's been a real pleasure spending the last couple of months building our product prototype with Ron Emmerich, with TK Kugler, with our Ukrainian designers, but above all with our interns, our iTeam as we call them. And as many of you already know, Alex and Jeff and Ken and Nathan are fun and humorous and hungry for knowledge. Not just Pokemons and fried chicken on Fried Chicken Friday and Fried Chicken Monday, Tuesday, Wednesday, and Thursday. No, these gentlemen are also fantastically creative. They are serious, they're open-minded, and just wonderful personalities. And far from being simply wicked mean hackers, which they are and have proved, these burgeoning computer scientists, engineers, designers, and entrepreneurs surely have a bright future in these fields or in any other fields they may choose. So I just want to take the opportunity to say thank you. We're not done yet. We have another week, but it's been great. Thank you for your energy, your enthusiasm, all the hard work. You've done real work, and you've done it well. Thank you.
Any questions about Treasure IP, kind of the overview of the business? If it's not painfully obvious, these guys have just built the beginnings of a startup. I mean, that's pretty amazing. I'm Ron Emmerich. I'm the Director of Engineering Innovation here at Wasabi. We did this last summer, and I'll kind of talk a little bit about non-engineering stuff for a second. We did this last summer, and it was kind of dropped in our laps, and we just ran with it. And we had a couple of David students from Pinkerton, bright kids. We had one from Hollis, Brookline. And by the end of the summer, we did some pretty cool things. But we walked away going, you know, how do we build something bigger, better? And I remember really all winter going, what are we going to do? What are we going to do? And it was over the winter, I'd say in March, a lot of this started to crystallize for me. And then I went and pitched it to TK, to Michelle, we all sat in a room. I met Bob at Sauhegan High School, and we saw Most Likely to Succeed. If you haven't seen this documentary, talk to your educators, get it in your high schools. David, promote it, get it out there. It's all about experiential learning, project-based learning. I walked out of there and I said, bingo, we got it. We got it. I came in literally the next day, talked to Michelle in that room right there, talked to TK, and I said, I remember that night, sending them, Slack in the morning. Long story short, we pitched it, they loved it, and it's awesome to be able to work in a place like this where they support this. It's phenomenal. I have to say it's the most satisfying thing, one of the most satisfying things that I get to do here, teaching, mentoring, coaching, especially. Even interviewing these guys was a trip. I mean, you should see how they interviewed compared to how they acted at unbelievable, right? Nathan? Yeah. Really. So we've taken them through the interview process, all the way through, I guess, demo day, and in a large part where they now present them to the community what they have done for the last 7 weeks. We'll finish the summer, and when TK ever said to me, "No, we're actually going to build a startup," I came up with some cool ideas. We built this, we built that app, stuff we could use internally here at Wasabi. He came to me. I remember he was coming, driving down the New York Thruway. Calls me up and says, "I got an idea. We're going to build a startup." I said, "Oh no." You bring them to the water, you give them a fishing pole. You know the story. Teach them to fish. These guys have knocked it out of the park. I know that's not a lot of engineering stuff, but they're going to show you a lot of engineering and education stuff. I'll leave that to them. But they have been a pleasure. To the parents, that's all. Without further ado, unless there's any questions about any of this so far. Good. All right, let's dive into the good stuff. We'll have Ken, Jeff, Alex, and Nathan all come up here, and we'll walk through everything that they've done, and then we'll finish up with a demo. Questions, answers, questions and answers along the way if you wish. There'll be a point between the presentation here and the demo. Please ask them what they did, how they did it, we'll love to answer this. So, thank you. All right. Let's go. All right, good stuff.
So we're going to start off with an overview of the technologies that we used. But the technologies that belong, if you see after that, goes away in the section that's mobile and Android, primarily focused with Android Studio. So we used the Android SDK to develop an Android application in the framework. And that embodied Google's material design standards to make an application that actually looked like Google wants it to look. And within the Android Studio and the SDK, we used a lot of technologies such as the asynchronous tasks, which allowed us to do things in the background, as well as using Android fragments and activities in address. And finally, in the Android Studio, we use something called Gradle, which allowed us to build all of our code out and produce a product at the end of the session.
The second kind of technology used was database technology. So the first thing was MySQL, and that's a language that allows you to populate databases, create the database where all the information is stored for our patents. And with that, we use Amazon Web Services relational database service to put our database up on the cloud so we can access it anywhere you really have internet. And the last part of this was the MySQL Workbench, which is our user interface that allows us to basically populate, update, upgrade, and put out our database as we build it.
There are some other general technologies that we used. Node.js was the framework that we used to build our actual server, and that whole thing is written in JavaScript. And so with Node.js, we used some modules. We used Restify, which is a module that lets you actually build the calls to the server to be able to communicate to it. We used Passport, which was our authentication module to protect the server from people who try to spam it or something, so that you have to actually have credentials to be able to talk to it. And Winston is a debugging tool because JavaScript doesn't really come with any help with debugging, so I made a lot too. Amazon AWS, that was where our server is being hosted. It's Amazon Web Services, and we're using three main services that they have. S3, which is a simple storage service that has all of like the patent logos and data sheets and stuff. And then we have EC2, which is our actual cloud computer. So when we run our filtering algorithms and stuff, that's being done through EC2. And then RDS is our actual database that holds our promoted patent information and our user tables.
On the client side, that is the Android app itself. Some of the libraries we used include Jackson, which allowed us to take JSON, which is an object format that the server feeds us, and turn it into something that plays well with actual Java code. We used Retrofit in conjunction with OpenHTTP to actually communicate with the server via HTTP, surprisingly. We also use Persistent Cookie Jar to actually hold a token given to us by the server, so the user doesn't have to log in every time they want to execute a search. And as for encryption, in order to secure the actual client's connection to the server, we used MD5 hashing to make sure that the password at no point is transmitted in a mutable way to a third party human in the middle. We also use TLS and SSL certificates for encryption from end to end to protect the data even further. As for languages, we use Java on the client side, so for the app itself, and we use JavaScript for the server. These two things are not the same thing. It's a common misconception because the word Java appears in both. It grinds our gears. We used HTML and CSS. Jeff did for making the landing page using Unbounce. We used XML for the actual UI on the Android app itself. Almost entirely XML. And JSON was the parser, the language that we used to transmit the actual object models between the server and the client. And we learned some German. One word is Verschlimmbessern, or Verschlimmbessern.
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 That's what he said. We're still learning.
Obviously, we're still learning.
And that means to try to make things better, but make them worse in the process, which we did a lot of.
All right, so for source code management, we all developed our code locally on our own laptops. So we had to figure out a way to be able to combine it with each other. So one tool that we use is called Git. And Git lets you take the code that you're working on and upload it to a repository where everyone's uploaded their code to. And let us do version control where if we had a specific task to work on, we can make a different branch in the repository, work on that, and then merge that back into the main branch. so that we weren't trying to edit the same line of code and cause us some issues. Jenkins is a tool that we used on the server because when we first started working with the server, we didn't really have a way to make it automatically stay updated with the code we were writing. So Jenkins is a tool that when we use Git to push our code, it will take the code and deploy it onto the server. And then using PM2, that'll actually restart the server code so it stays up to date as we're developing it. Atom.io is the development environment that we used with JavaScript.
Gradle itself is a platform that actually compiles the Android app, and it also manages dependencies, so libraries. Maven is the repository where Gradle will go and get the libraries from and keep the most updated version. It basically removes a lot of PS work because things are being updated constantly, and it probably would have been a disaster without it.
Oh,
That's the Jenkins error.
and that's Ron messing up. My bad. Duly noted, David.
So next we have our computer science in action. So this is where all the really cool stuff you learn in those programming classes really gets applied in the real world. So things like searches and sorts we did a lot of here. Searching, obviously, we're searching for patents. So a real search is able to locate that patent more effectively. Sorting the patents, a lot of times we sort by relevance here at Wasabi. And so like things that have more keywords in them will pop up first on your results list as more relevant. Other things we do, such as filtering, we can filter by date ranges and by patent type so that the stuff you don't necessarily want doesn't actually show up in your search results. Things like logical checks, we deal with nulls. So if a null comes up in the database somewhere, we don't want to show that to the user, so we handle that. We make sure it doesn't throw any errors, and we make it look nice so the user has a good experience with the app. Multi-threading is very useful. So say you want to execute a search, and the app would freeze up if you only ran it on a single thread. So with multi-threading, you can execute the search and still play around, scroll the app, and see what you've already got while it's getting you more information. Caching allows you to store information locally so that you don't have to re-execute a search to get it. So say you click on an app and you want to learn more details about it, but then you go back to the results page, it's already going to be populated. Dynamic pagination allows us to have a single page that seems to the user like it scrolls infinitely, like all the patents are already there, but what's actually happening is as the user reaches a threshold, the patents view will start to populate more results onto the page in a really dynamic manner so that to the user it looks like one big page, but it's actually a bunch of pages dynamically added onto each other. And code optimization is a really big one because originally when we first designed the app, it would take over a minute to populate results from patents view. And after we did some optimization, did some cutting down, reorganized some server stuff, all of a sudden we were getting it down to the search results populate just a couple seconds now. And for performance enhancement, that's things like dealing with memory and CPU also. So if something's taking up too much memory, you want to limit that because you can cause crashes to our AWS server, or if you're using up too much CPU, the app might start lagging, and you really need to cut down on that.
So to make an application that the user is actually going to use numerous times and not just delete after their first use, it has to be pretty fluid. So to do that, we needed some designs. So we used wireframing tools such as Proto.io, Envision, and the advanced whiteboard marker to make some prototypes. After we made a couple After we made a couple prototypes, we brought David and Ron into a room and had them user tested where they shredded it. But
Very uncomfortable.
we used David and Ron as guinea pigs to test their prototypes after we made them a prototype.
Some of the other tools we used Untitled, which was a project management tool. Our source code was actually stored as we were developing it, and it had some cool planning tools where we'd sit down, figure out what tasks need to be done for that week, and then create tickets for each of the tasks so we can check it off as we get them done. So we always have a plan of where we're going. Another cool tool we used was Slack. This was our main communication tool. It's kind of like a chat room for the office. We had different channels. We had a design channel, we had an engineering channel, we had an interns channel. And the cool thing about this, what it let us do is we were working with some Ukrainian developers and designers, and we could talk to them and share files with them. So whenever we had a whiteboard session, we could just snap a picture of it and send it right over to them. Made it easy. And SSH and SCP, those are how we connect into the AWS EC2 computer. We connect in through SSH and then we can do command line codes to that. And then SCP is how we copy our files onto it.
So to throw an incomplete list of all the technologies we use into one slide, this is really what
Maybe the thirsty moose too, I don't know.
It didn't all fit on the slide. There was more. It didn't all fit.
I'm Nathan Knight. I just recently graduated from Plymouth Regional High School. This upcoming fall, I'm attending the University of Waterloo for honors computer science. I'll be in the co-op program as well. I gave myself the title of full stack engineer because I'll let me work on the back end too. I did client-side networking, so as I mentioned before, with retrofit and OpenHTTP. So Alex did the first pass, and I rewrote it to make it more optimized and have better error handling, as well as have more flexibility, including authentication. I also am working currently on the full registration stack, so on the client side actually entering the email, the password, and sending it, and on the server storing it, and Ken's doing retrieval. I also am working on Google Single Sign-On. I also did the first pass on app structure. So I did the first wireframes. It was on one of the first days we were here. And Ron asked me to make some wireframes for the app. And I did. And then David took me into that room and tore them apart. But I think some of it still made it through to the final product. Well, not the final product, but what's approaching the minimum viable product. We also, when we first made the app, we decided every screen was going to be an activity. And so I made that on the first day, and that got completely scrapped, every single bit of it. And we redid it completely with fragments. That's progress. I also, one day early on, when I was eating lunch, read Google's material design spec. And it was very extensive, and I became the de facto material design expert.
That was a long lunch.
It was.
Sure, right?
It was a long
Yeah.
launch, but it was a valuable launch. Material design is Google's design framework for every Android app. So they want apps to all have a certain unified look and feel, so users intuitively know how things work. It also applies to their web platforms. It covers obscenely small details, from like app timing or animation timing to different like logo like edges. So I taught myself that, and I believe I was pretty useful throughout actually designing the app and applying this mindset. The logos, the images, every single image asset, icons. And we also encountered numerous Git versioning issues. If you ever used Git, you probably know the pain. So every other time we tried to merge our code, it would throw up a few hundred errors and everything would break. And I think I got decent at fixing that. And hopefully it came in handy. And Git blame Ken as a joke.
So I'm Jeff Johansson, and I recently graduated from Southeastern High School, and I'm going to the University of New Hampshire for computer science in the fall. And I worked as a UI engineer. I worked on the client side, so everything that had to do with the application. And one of my main jobs was to work with the Android SDK, so I didn't actually know what XML was before I came here, and I learned that in a couple days. And it's a very useful tool in the Android Studio. It's actually required to make an application that works. But part of that is to make everything pretty, and that's important because if you want people to use your application, you want the engine to be used, and to people to get what you're putting out of the application, it has to feel right. All the elements have to look correct. So that was a huge part of my job. And later on in the internship, David approached me with a challenge. In an afternoon, he said we needed a landing page up by the end of the day. So it was about 2 o'clock at that point, and I really hadn't made a landing page before, but I used a little HTML and CSS and a tool he gave me called Unbounce to put up a landing page. And you can actually see it on treasureip.com right now if you like. Another challenge that I had at the beginning of the internship was applying something called filter logic. You all know if you search for something, you have search filters, but where do you put them? So our initial idea was to put them in a dialog, so just a pop-up box that had an OK and cancel button that would just go away eventually, and it just didn't make sense at all. It was a horrible idea. So there were a couple rounds of
I
design.
think it was my idea, right?
Actually, it was Ron's
That's
idea.
why it was horrible. I went on vacation, came back, and everything was changed.
That's actually exactly what happened. Through a couple rounds of design iteration, actually one of our designers, out of random, made an app drawer that slid out with the filters, and we loved it. So we started to integrate that, and he solved the problems for us. But I'm also currently working on Facebook single sign-on, so that you can sign on with your Facebook account and not have to worry about security issues, because Facebook will handle everything.
I'm Ken Cole. I recently finished my junior year at Wyndham High School, and in the fall I'm starting my senior year at Wyndham High School. So I was one of the back-end engineers. I worked server-side programming in JavaScript with Node.js. The interesting thing about that is I was hired to work in Java, and then third day on the job, run through the curveballs and learn JavaScript.
First, you can't believe it.
So I worked with building all the APIs. So the Android app would make a call to our server, and then our server would make a call out to Patents View, which is the United States Patents and Trademark Office API. So we'd call it back, and then they would hit us back a lot of patent information. And then through the algorithms Alex implemented, sorted those, filtered those out, and then returned them back to the client. I worked with the DevOps or development operations through setting up Amazon AWS and setting up our continuous integration server on that with Jenkins, so that whenever we develop new code, it would automatically be put in for us.
I'm Alex Johnson, and I recently graduated from Wyndham High School, and I'll be attending Rensselaer Polytechnic Institute for Computer Systems Engineering and Computer Science in the fall. I was also with Ken, a back-end engineer, and at the beginning of the internship, I was working with Java. So I did all this kind of HTTP connections and kind of the server algorithms on the Java side. And about halfway through, when Ken showed up, we ended up switching to JavaScript in our Node.js server. Here I actually have a circle, and it kind of shows how an algorithm is built and how it's implemented. So first, an engineer, or as what we did here, we would design or we'd discover a problem that we needed to solve. And so we need an algorithm to solve this problem efficiently as possible. So we would go through this phase where we design and analyze and kind of see how the algorithm we came up with fixed our problem, and we would implement it and experiment with it in the actual application and see how that worked. And then it's a continuous circle, so what we would do is we would go through and make more iterations and continuously improve it. And I think Ron always likes to say, make it work, and then make it work better. So that's what we did here. I handled a lot of the algorithms that are apped on the server side, such as searching and sorting. And actually here, this is one of these searches we implement. It's called a binary search, and what it does is if you have a list that's already sorted, say in alphabetical order or by number, and you know how it's sorted, you can really efficiently and quickly find if an element exists within this list. As shown here, it only takes about 3 iterations to find number 22, which is the target. Also, I built the data model that we use to store the information received, all the patent information, so the UI guys can really easily access it and display it for the user. I also dealt with some data normalization, which would be kind of your null checks, make sure everything looks pretty and is handed back to the UI guys in a really easy manner to use. Also, the data access layer is how we access our MySQL server. So basically, it's a connection to and from the server. You can do posts and gets where you can modify the data that way. And finally, at the beginning of the internship, I was working with the API at Patents View in Java, and then when we made the switch to JavaScript, I handed that off to Ken.
So over the course of this internship, we've been working on building a startup, but that truly begs the question, what is a startup? And that's where the Wasabi Ventures Academy came in. Over the course of the 6 weeks that we've been working on it, we learned a lot about startups and founders, due diligence, all the way down to pain points, and how to formulate a pitch deck. And my overall experience with this has been great. This is my second time going through this course.
He wasn't very good the first, so we made him make this was all remedial.
Yeah. I really want to be a founder here with Wasabi, so I think it's an awesome way to get introduced with TK. Obviously, he seems to know me fairly well. And it's an awesome way to learn.
My overall experience with the course, this was my first time through the course. Coming into it, I didn't really have a lot of knowledge on the startup world and the differences between startups and small businesses. So just getting exposed to that is pretty cool, learning all about startup ecosystems and pain points, as they're called. Because if you have a startup, you need to make sure it actually solves a problem people have, or if you're going to buy your stuff. It's a pretty good learning experience.
For me, I think what really hit me on the experience was how you watch a lot of videos, and the videos are from TK and Chris Ye and other guys who worked their whole lives with founders and being a startup. Some of the videos also work with current entrepreneurs really doing their startups. So all the stuff you've learned is coming from like directly from the real source, from people that do this every day. And I think the kind of insight they have towards becoming a founder yourself is really insightful.
For me, the most valuable part was actually learning about focusing all of the ideas that you have using pain points and then turning that into a pitch deck. So along the way, I had quite a few ideas for startups, and some were definitely better than others. And I'm actually really excited to be putting together a pitch deck right now, and I hope to have the opportunity to pitch it.
So, before we get into the demo, any questions? There must be. Yeah, feel free.
I thought that it's an amazing amount of technology you guys integrated. How much of it was given to you, and how much of it do you guys have to figure out how to piece together?
Almost all of them.
Yeah, most of it we would get the technology, but then we would have to figure out how to apply it to it.
I'll just kind of interject something that I thought of as they were talking. They all came in knowing, I think, Java. They didn't know Node, JavaScript, Android at all. Let's see what else. Really, just about everything on that list I've never seen or heard of. So it's pretty cool that they built this app that you're going to see, and they had to learn everything on the fly in real time. They were really quick learners. So, testament to them.
I'm just wondering, for each of the guys, so when did you first get exposed to coding? How and what were your educational experiences like? I mean, like CS courses did you take? What kind of opportunities did you have in your education?
I first got started programming in middle school, Minecraft modding, of course. So I got started with Java, and I had some success with that, and I really enjoyed it. And then in high school, I was lucky enough to move regional high school to actually have courses that I could take. So I started off with VB6, really liked that, took Java, and they didn't have a third course, but I petitioned to get C++ added, so I took that my junior year. And my senior year, I spent a lot of time programming independently. But I would definitely say I wouldn't be where I am today if I actually hadn't had a formal classroom setting. There was a lot of opportunity afforded by that.
I got introduced to programming probably about my sophomore year of high school, and it was from a teacher, some of you know her, Miss Nickerson. And she just introduced me to the idea, and I just kind of took it and rolled on my own. I started doing a lot of development on my own. Like I would think like what kind of things did I wish I could do on my computer? And I was like, okay, maybe I can develop that. Maybe I can fool around and see what I can get. And then a lot of that I got knowledge on how Java libraries work, how the basic syntax works, how different algorithms can be implemented to really achieve things in a good manner. Also, I really enjoy challenge problems, so I'd go on, there's this website called hackerrank.com, and I would go on and I would just be like, okay, let's solve this, and like I would go through and say like, okay, I solved it, but there's runtime errors, or it's too memory inefficient, and so I'd go through and I would learn different ways to attack problems, and that really came to my benefit when learning how to code. I think I learned a lot of what I know from that website alone, and just figuring out how to attack problems.
Was it introduced in a specific class at your school?
Yes, I took a class called Object-Oriented Programming. I'm going to say it wasn't the greatest class, but it really introduced me to the idea of programming, and I took that idea and just kind of ran with it, and I've developed a passion. It was awesome. I also, I did take the AP Computer Science curriculum, but by that point, I already had come across a lot of the things they taught in that course because it's an introductory level course. But it helped to reinforce some of the ideas I had already learned on my own.
I actually started during my sophomore year with VLEX, and I took Python and Java, and I think Python's a great way to start. But I didn't have a lot of direction to go after that, because Savigan offers not a single computer science class, and they refused to. But I met someone who worked for Dyn in Manchester who started the co-op. His name's Ali Raffinair. And
Oh, yeah.
If you know him, you know exactly what I'm talking about.
Everybody knows all that.
He brought me through and he gave me access to courses paid for by Dyn actually, for object-oriented programming, intro to C++, intro to Java, TK's course as well, and an internship. So I think the way he brought about that progression of learning through problem solving and then learning through problem solving, the internship that he created, it wasn't so much an internship per se like this, but it was a good way to start to learn, just to have a deadline to push a product and to build something.
I got started in middle school playing around with something called Visual Basic, which is really a real program.
It's very visual and it's very basic.
You don't have to tell me.
Started doing things like making a tic-tac-toe game, stuff like that, and then near the end of middle school, I got my hands on a Raspberry Pi. I started playing around, programming some Python, and then freshman year, I joined my school's robotics team. And freshman year, I worked on mechanical design, and decided I wanted to be a programmer on the team, so I started doing Java that year. And then, beginning my sophomore year, I started doing some programming for the robot in Java. And then, this past year, my junior year, I joined my school's programming team. Did some programming with that with Alex. And then, this fall, I'll be taking my first computer science class.
Strange.
Good luck to the guy.
It might help teach it. Anything else? We can maybe
This is
take
awesome.
one more, we'll go into
This is awesome, but you never mentioned the word test. So, did
Yeah, my fault.
Did you write test cases? Yeah, just describe it.
You guys can blame me.
We haven't had a chance to do JUnit testing yet.
Yeah.
That's something that we've been thinking about doing.
Yeah.
But mostly we've been finding errors by breaking.
Yeah.
I think the other thing to remember from a business standpoint, this is real business. So
Yeah.
Treasure IP will live after this. This wasn't a made-up thing. We're sticking, no offense, real engineers on this after the summer. So this was purely meant to build an MVP. And if you don't understand MVP and lean, you're really building something you know you may throw away.
Right.
So testing and unit testing, while nice to haves, are not essential. And that's really how the real world works too. We're building something and we're going to throw it against a wall, and we may wind up throwing everything away because it's about speed at this point.
No, it's awesome. The question was
To their credit, they asked about it and they have it still. And because of the unique situation that we're into, I think trying to get the testing isn't always fun. So we're having some fun this summer.
Yeah.
So why don't we jump into the demo? They can walk you through it, and then we'll have plenty of time for more Q&A, chit chat after this, and food. So you get that fire up.
This is the part where conventional works on it.
It's worked in all of our warm-up, like, tests.
Right, this is different.
Yeah. It's when it falls apart.
Coming up. I'm sorry, Chris. We'll be good.
It's an applicant.
It's a great language.
They will anyway.
Blame him.
Oh, this is coming up. Have any of you dabbled with doing development in Unity?
I do a lot of weird development.
All right, fellas, here's your app.
All right, so immediately you're greeted with the home screen and the logo. Hopefully it's apparent that if you were to click there.
Visual cues. Visual cues.
So if you were to open up the nav drawer, that's one of the things we talked about. Here you're going to have basically quick navigation things, so settings, wish list, dependency, and also sign in. That's a temporary button. It's going to look cool later. Once you're here, this is where you enter your credentials to log in. We also have a functional Facebook and Google single sign-on. So if you were to go back and click them, you'll see it actually pops up with it. We actually have it already implemented with their APIs. Just needs to be implemented server side. Same goes for Google.
We're seeing all of this inside Android Studio.
Yes. This is, yeah, we're running on the same thing.
So that's an exciting part. This is currently work in progress. This is something I was working on, generally the screens, and I'm making the voodoo in the background. So we can go to search.
Oh, you want to show?
Oh yeah, there's cool animations.
If we navigate back to the home screen, we can actually forward search. Then when it's a word that you'd like to search for, just yell
Any noun.
Any noun, anything.
Nano.
Nano?
Nano? Okay, here we go. Boom.
Okay, so this is the results page, and we made it here. So on this page, there's actually two different types of patents. So there's the patents that just come straight from the database. We're actually going to have our own database of patents from the labs that David mentioned, and they're going to provide additional information, so like logos and stuff, as well as what's called the technology readiness level, where we indicate to a potential buyer how close it is to actually being ready to use the real application. You'll also see that we'll have additional documents and photos accompanying them. At the moment, if you scroll down, you'll be able to see dynamic pagination in action if you scroll down approximately 50. There you go. So just loaded another 50. Okay, and so
If we navigate to a details page, you can see the basic details. If Ron will click on some of the badges, eventually there'll be more badges based on the patent, whether or not it's promoted, and you'll be able to horizontally scroll. You get the title as well as a truncated abstract. Now, if Ron were to go to the bottom of the abstract and click See All Patent Details, you get a list of everything pertinent to the patent. It starts with the abstract and moves on to the inventors. There is a list detailing all the way down to the patent ID and title of the citations. Patents that cite this patent, or the patents that are cited by this patent, as well as a doc tag of all the information pertinent to it, like its ID, its year, the relevance of time, and its location.
Can I search on a patent number or like if I knew an inventor's name, could I do that?
that will be
It will
Yes.
be being implemented.
It's in the list, yeah.
also if we open up the filter menu, which is in the top right corner. You'll see this is actually the idea that one of the Ukrainian designers came up with. We had the dialogue, he suggested this, and it was great. So you can actually set the year using these, and these allow you to select only these types of patents. So if you only want to design patents, you check there. So once you've selected a year, and the back page to the query, you'll only see patents from whatever the year was 1980 something to 1982 onwards.
Oh,
And only design, so there are no design patents.
there are no design
If you
patents.
go and choose, say, utility ratio. It's filtered out all of those.
The reason why it said 2,500 both times was not because we didn't filter anything, but rather we cap it at 2,500.
Just so that the server doesn't die with a 10,000 patent request.
And nobody looks past the second page.
MVP. That's pretty much the app, right? Anything else you guys want to show?
I got something exciting.
Any questions about that?
Is it patented?
Any questions?
So, yeah, I've got a few questions. So you're obviously testing right now on an emulated device, but what process and thought have you put towards what devices you were going to be targeting and OS levels, things like that?
So we chose KitKat because the vast majority of enterprises these days support it, banking for that. This is some things, although ideally you want to have Lollipop or above, because that's when Google introduced the material design spec. So a lot of the pretty looking things are not pretty if you are using the KitKat phone like I am.
So, but it does degrade into that nicely.
It still works.
Okay.
The target is Marshmallow.
Yes.
Right.
We have tested it on our actual phones.
And tablets as well.
It works on tablets, although we haven't specifically designed the UI to work on tablets, so it doesn't make full use of the extra display real estate.
Is that part of the, I haven't done much with the material UI, is the material UI have a little bit of responsiveness to be able to deal with that?
And then we use like the Gmail app on the tablet. So basically we just, for example, have the search on the left side, actual details on the right side,
I see.
and you don't have to transition between screens. Theoretically.
Any other questions? Yeah.
It looks great.
Good job, guys. So what patents did you find while working on the app that you were excited about?
Oh, we found this one guy who had a 40 chemical.
That's all an outlier, right?
Yeah, it broke the UI.
There's scone patents.
Yeah, we found like patents on scones.
While in an early morning eating scones, we searched for scones.
Found a few bugs.
Yeah,
That was tested.
That's awesome.
Security was a big one as well.
yeah.
I have a way of breaking it as soon as they come running over to my desk. Ron, it works. Okay, and I magically break it. Really good at it.
At one point, we crashed the server by executing a single query because we did not cap how many things we take back.
Yeah, that was a lot of patents.
There are a lot of things.
There's a lot of things that break the AWS server.
Was the patent API that you're calling that have a rate limit to it? Did you have to deal with to capture it?
No, the government's good like that. Right? It's a government API.
So naturally so.
When we first started, it would take like 2 minutes to get data back.
But we also learned how to query. We got smarter. We optimized how we query the API. A lot of learning. Anything else? Anybody? Questions?
This is a bit of a test.
Oh.
What is the single most important skill you've learned this summer?
How to learn.
How to learn.
And also, what was the greatest challenge you faced?
Everyone.
JavaScript.
JavaScript.
Wait, asynchronous and callbacks?
Well, and the debugging, it gives you like a single line without line numbers, and it's like cannot find length of null, and you have no idea what that means. and then you realize that it's when you set a variable, a soft type variable to a boolean, it's for some reason treating it like a string, not a boolean.
One challenge that I encountered that was an absolute nightmare was on the emulator, as you saw, it actually showed like a picture of the phone around it. And I was trying to set it up so it would work differently depending on the screen size. And inexplicably, if you have that enabled, it actually functions differently. And I did not realize this for about 3 hours since I tried to figure out what was wrong with my code. Turns out it's an emulator bug. Feature.
He didn't read the document.
It was like one obscure checkbox in the setup.
Challenge I faced for the most part as a UI engineer is I never make anything clean or pretty, and it usually doesn't come out very well. So I kind of had to do that for the client. So it was a lot of work for me to make a wireframe that looks not like chicken scratch or anything that wasn't trashy. But it was a good challenge to have because now I have a better. Now it's better to make something cleaner.
The biggest challenge I faced was definitely JavaScript. Because there are things that if written in Java would have worked, but it didn't work, and I couldn't figure out why. Like hours on end sometimes.
The S, right?
Yes, we got an error, S is undefined. And after like 2 hours, we figured out there was an S on the end of one of our lines of code.
Yeah, it would just compile and run, but in that line just like would run.
Yeah, we get that error like a third of the time.
Yeah, with the same code. I think the best thing I learned was how to program and develop in a business environment, which is, I think, going to be one of the most helpful things in my future when working out of school.
If I can redo what I said was the best thing that I learned, it was probably developing a team environment.
Yeah. And I agree with that. Learning how to communicate with the team. Nathan's making the details page at the same time I'm making the details page, and then he pushes to Git, and I pull it and destroys everything in 3 hours.
Kids playing Nathan now.
So, I gotta ask one more thing. Have you thought about like how you can maybe present this back to your school and help recruit, younger engineers or get younger people interested in some of the things that you're involved in?
I mean, I tried, Ron actually wanted to get in contact with my programming teacher for potential future students.
Yeah. But it would be powerful coming, like, with your voice can be powerful for younger students.
David,
Ken
take
doesn't
him on the
notice
road.
that
Tell
you're
you,
gonna
baby.
sign that
Take him on,
product.
take him on the road. Yeah, take him on the road.
Something that you may not realize, being that you're new to JavaScript, but not that many years ago, your presentation would have been very different. The JavaScript would have been your front end, and the Java would have been the back end. It tickles me. It's just the bottom line for that, actually, I guess my message to you is whatever you're doing in programming in today will not be the same in 10 years. One of the apps that you saw in there is called Envision. A couple of my buddies founded that company, 250 people now. It's used by all kinds of companies all over the world. Those two guys I met at a conference, we got together at all the conferences, we all programmed a language called Cold Fusion, which no one uses anymore. But that's the stem of the chain of things. You continue to iterate and learn, and keep monitoring new technologies, update that giant bullet list, and then you find your path to success. So you're well, anyways. The fact that you're using Git and you're not even in college, it's like you're world above half the college students.
Yeah. You're gonna be bored by your freshman in sophomore.
Yeah, I was going to say,
Maybe junior.
there's plenty for that.
Yeah. You have to start a company in college. Make some connections.
So thanks everyone, and obviously thanks to the students. I actually wanted to close with answering your question of what's the greatest thing they learn. And if you listen very, very carefully, and it's lost on them, is that the greatest thing that they'll learn, and they hinted at it, is the ability to work in a team, and to work in a team that is very, very diverse, all the way from the business side of the shop, plus geographically. Wasabi has 20 engineers that are in the Ukraine, 7 hours ahead. And that's a totally foreign concept for them that they would have been able to do that. And so it's those skills, because the languages will go away, and you'll have to start all over, and the actual technologies built here will be thrown away, more than likely. But those things are what are very valuable, and that's the beauty of experiential learning, is that that's the things that they really learn. So thanks for coming today. Please eat all of the food. I'm going to take none of it home. So thanks for coming.
Thank you.
Feel free to stick around, chit chat, and make